Over here, what I'm going to do is that I'm going to also use these two functions, which are very important for you to actually understand, which is strp time and then strf time. Okay, we're going to see what these two functions mean, right, and how we can use in when it comes to formatting the date, right, how we can use them to format the date. Now, if you're working on projects, it's likely that you'll be working in different time zones, right, or you'll be working with different countries that are having different ways of imputing date and time, right? So you need to actually take care of that before you can actually have something meaningful, right? When you're performing data analysis, or even if you want to build a machine learning model, you actually need to make sure that your date and your time is actually in appropriate order before you can actually proceed, right? So if you take, for instance, in the US, you will see that the date is represented as month, then the day, then the year, right? However, if you go to the UK, it's actually going to be day, month, and then the year, right? Instead of month, day, and then year, in the UK it's going to be day, month, and then the year, right? The day will come before the month, but in the US the month will come before the day. Okay, so it's a different way of representing date, and you have to be careful and critical about this when you are dealing with when you have a data set which contains date and then the time when you're working on it. All right, so let's see these two functions, which is strf time and then the strp time, right? So let's see these two. So the first one that we're going to talk about is strf time, right, which is used to convert the date time object to string, right? So str here is string, right? So string from time. So we're going to get a string out of the time. Okay, so let's see how this is done and how we can do this over here. All right, so I'm going to import my date time over here. Then I'm going to print the current date and then the time, right, using this. So I'm going to use datetime.now, which is going to give me the current time. Then I store it in a variable called now. All right, now what I'm going to do over here is that I'm going to use this strf time, right, to create a string out of the date that I have, and then I can specify the format that I want in terms of the hours, the minutes, and then the seconds. Okay, so I want the hours to come first, the minutes to come second, and then the seconds to come last over here. So I'm going to print that T for you to actually see. So let me actually let me comment these ones out. All right, okay, and then run what we have. So now you see that the time is having these hours over here, and then we have this kind of minutes and then seconds. Okay, just like I specified. I can also add the date, the month, the day, and then the year as well, right? So let's actually do that, right? So if we want to do it in the US format, right, in the US format, it's going to be the month, the day, and then the year, right, as we talked about earlier on, right? So in the US, it's going to be month, day, and then the year. So that's what I'm going to do over here, right? I can format the data that I have so that if the data set, or if the company that I'm working for is a US company, and I need to make sure that the date is corresponding to the domain that I'm working with, right, which is the US, I can format the date in that way. Okay, so I want it to be month. So irrespective of how the date has been arranged, I can format it to the correct order. So I want it to be month, day, and then the year, and then the hours, minutes, and seconds over here. Okay, so if we run this, you see how we have it over here, right? We have the month, which is January 17th, which is the day, and then the month, and then we have the hours, minutes, and then seconds over here. Okay, if it is a UK, right, I can also do it in the same format, right? In the UK, it will be day, month, and then the year, right? Unlike US, which was month, day, and then the year. All right, so if I run this one, okay, now you can actually see the difference over here, right? You can see the difference over here. Let me actually do this one as USA, and then do this one as UK. Okay, now you can see it's clearly here, right? So you can format your date and time accordingly, right? So it could be it could be Asia, which China, or in India, or whatever that you are working with, time zone that you're working with. You can format it accordingly. Okay, Now, the next thing that we're going to, talk about is how to extract the year, the month, the day, and then the time using the strf time, right? So earlier on, we just extracted them without using this function, but we're going to see how we can use the strf time to actually extract this as well. Okay. So let's proceed and see how we're going to do it. So the same format, I'm just going to import the date time. Then once you import it once, you don't actually need to be importing it over and over again. So I can just get rid of it. All right, I'm just adding it over and over again, but you can get rid of it. What I'm doing over here is that I'm going to create another date time.now over here. Then the year over here, what I'm doing is that now.strf time, and then I put in only the year, right? So in this case, I'm not going to put in the day, the month, and then the year. I'm just going to put in only the year, right? So that I'll be able to print the year, right? So let me actually comment these ones out. All right, let me do this, comment them out, and then print this one for you to see. Okay, so now you see that the year is 2021. If I want to print the month, right? If I want to print the month, I just put in the M, right? Which is for the month, right? So if I do that, now you see that the month is January, right? Which is 01 over there, right? I can also print the day as well, right? I can print the day. Now you see that the day is 17th, right? I can do it for all of the others as well, right? So let me comment all of them and run. Right, so we see that we have the time, right, and then the date and time all together over here. All right, so that's basically how you do it if you want to extract them individually. All right, now sometimes your data will not come in and then having the dates like we've seen here, right? It will not have it in this way. It will have a timestamp, right? So let me show you what timestamp means and how you can also do a timestamp, right? So just the same thing, import your date time. So timestamp could be in this format, so it could be any hypothetical timestamp that has been there. Not hypothetical as in hypothetical, but it could be time, it could be numbers like this, which represent some years, some months, some days, some hours, all of them put together in this format, right? So you are the one who's supposed to format this one to the correct order, all right? So you don't know what that numbers mean, so it could be something, maybe 7, 8, whatever numbers that are there, right? So you need to format this one to the right order, right? Because this represents the day, the time, everything put together in this form, right? In this format, which you refer to as timestamp. Okay, so if you want to actually do this, what you're going to do is that you're going to use what is referred to as from timestamp. Okay, so date time dot from timestamp, and then you put your timestamp in here, right? So I could have put the numbers in here, or I could have just create a variable for the timestamp and then put it in here, right? Then after that, I can now print the date time that I've created. So let me show you what that means after I've been able to convert this one, right? So let me comment these ones out. All right, so if I convert it from the timestamp to date time, right, to date time, let's see what these numbers mean. Okay, now you see that is this one, 1995, right? January 4th, right? It's January 4th, 1995 with this time, right? 15 hours, 12 minutes and 0 seconds. But when it is like these numbers, you don't really know what it means, right? You don't really know what it means. But from timestamp can actually help you extract the day, the month, the year, and the time from that. Okay, so maybe I want to even see it, instead of maybe this format. So this is January 4th, right? So sometimes it gets confused whether this is the month or this is the year. This is the day and this is the month, or this is the day and this is the month. Sometimes it gets confusing, so I can actually specify over here, right? So let me actually comment these ones and then run it for you to see. Right, so in that case, you see that it's actually specifying that it's 4th January 1995. So I don't need to figure out which one is the day, which one is the month, right? Otherwise, probably I would have said that it's 1st of April, right? 1st of April. Meanwhile, it is 4th of January, right? So I can use this format to also do that. So the day, right, and then the month, right, and then let me undo this, the month and then the year, right? That will actually help me to get it in this form, so that I'll know which one was the day, which one is the day, and then the month. Okay, I can use the small b just for the month, or I can use the capital B, or either of them is just going to give me the same thing, right? So if I run it, you see that's actually giving me the same thing. So the small b is just going to shorten it to Jan, but the capital B is going to give you everything, like 04 January 1995. All right. Let me uncomment this one and run for you to see. All right, so if I want to actually see the time, right, the specific time that is associated with this timestamp that I gave over here, right? So it was 3 p.m., right? It was 3 p.m. in 4th January 1995, 3 p.m. Right, so I mean, depending on the data set that is coming in, we will have numbers like this, which it doesn't make any sense. But if you use from timestamp, you can actually make sense out of the numbers that you have, or the timestamp that you have, right? So you can be able to see that 4th January 1995, 3 p.m. is when that event happened. Okay. Now let's go and see this model as well, which is the SGLP time, right? Now let's actually use the F1 score to also see how this works, the F1 and then the recall. Okay, we can also use that one to check. So if we use the confusion metrics instead of the accuracy, right, we are now changing our metrics, right? We are changing our performance metrics over here. So we've seen the confusion metrics. Now if you use the accuracy, just the accuracy, you'll be thinking that your model is doing 99. It means 99.6, almost 100%. It means that it's almost predicting all the zeros as zeros and all the ones as ones, right? But you can see that that's not the case, right? It's actually making mistakes in there, right? It's making a lot of mistakes in there. But if you check only the accuracy, it's actually showing that our model is almost correct. It's not making any mistakes in there, right? Maybe about 1 or just 2 mistakes, but you can see as much as 19 plus 7, right? Which is quite high, right? We don't actually want to do that. So if you change the metrics, it's actually going to help you. Now let's see the F1 score and then the recall as well. All right. So for F1 score, we've already imported this F1 score function, right? If you see earlier on the libraries that we're importing, right? So from sklearn.metrics, import accuracy, and then the F1 score, confusion metrics, and recall. Okay, we've imported them. So let's actually see how we use them over here. So what I'm going to use is the F1 score, then I pass in the Y test and then the logistic period. So just the same thing like we're using for the accuracy. If we were to be the accuracy, we would have written here maybe accuracy score, right? Could have been accuracy score. If the confusion metrics, we could have written here confusion underscore metrics, right? We could have written that, right? Confusion underscore metrics. Okay, so we just the same thing, just that depending on the performance metrics that you are using. In this case, we are using F1 score, so F1 score, right? And then we pass in the same data. Now if you go to the recall, it's just the same thing. Recall score, you pass in the data. All right, then here I'm just printing the score, right? I'm just printing the score. So let's see the output of the two. Now, if you see the F1 score over here, you can see that we have 0.55, which is just 55%, right? Now, if you see the recall here, you have 69%. Now, if you see the accuracy that we're seeing, 99, accuracy was giving us 99.9 0.96, right? 99. This is for logistic, 99.5, right? Which means our model is doing very well, right? If we just use the accuracy. But the F1 score and the recall is actually telling us something different, right? With that kind of performance, with that kind of accuracy, we expect our F1 score to be as close to 1 as possible, right? Or as close to 100% as possible. But you can see that it's just somewhere around 55% or 0.5. Okay, now if you see the recall, we also expect the recall to be as close to 1 or 100 as possible, but you can see that it's just 0.6 or 69, right, percent. And I mean, it's you can see that the accuracy was deceptive, right? If we're to use only the accuracy, it's actually deceptive. It's not actually telling us what we are supposed to know. So changing the performance metrics actually helps to let you know what the reality on the ground and what is actually going on. Okay, so now that we know this, the different performance metrics that we can also use as and not only stick to the accuracy. Let's also see the other ways that we can deal with this data imbalance. Okay, so we can also change the algorithm, right? We can also change the algorithm. Now we've used demi classifier, and then we've used the logistic regression, right? Now if those algorithms are not helping us, we can change it, because we have a number of algorithms that we can use for when building machine learning models. We have a number of them. So if one is not working for you, you don't stick to it. You can change the algorithm and then use a different algorithm to build your model. Okay, so now let's actually change this algorithm, the logistic that we are going to use. Now in this case, we're going to use what is called the random forest, right? Random forest is one of the robust models that you can actually use when you are dealing with or building machine learning models, because it's actually going to combine a lot of different algorithms, right? And then give us the average accuracy of that, or average performance of that. Okay, so let's actually use the random forest over here. So since this is a classification problem, that is classifying whether a particular transaction is fraudulent or not fraudulent, right? So in this case, we have a classification problem. So I'm going to use random forest classifier, right? If it's a regression problem, like predicting, let's say, the price of a stock or something like that, we're going to use a regression. It's a regression problem, so we're going to use random forest regressor. But in this case, we're using random forest classifier because we have a classification problem. Okay, so now that that one is done, what we're going to do over here is that we just have to initialize it, right? So random forest classifier, and then we initialize it to just a variable over here. You can just create it any way that you want. So I'm using RFC for just random forest classifier. You can just maybe create it as model or whatever you want, right? As model or whatever you want. In this case, I'm just using RFC right over here. So after that, I use RFC.fit, right? And then what I'm doing here is just to learn, right? Let my model learn from the training, the two training data points that I have. That is the S train and then the Y train, right? The two training data set that I have. Okay, now that my model has learned from these two training data points or data set, what I'm going to see over here is that if you run it, you're just going to see all the default parameters in here. Don't worry about these default parameters, right? You will see more of these when you get to the machine learning course. Okay, now what is happening over here is that, let me actually do this. I'm going to make the predictions, right, just like we did earlier on, right? So RSC does predict, then I predict using the test data, right? Then I store it in a variable called RSC pred. Okay, then I use the accuracy again. So you see that this time I'm using the metrics to be accuracy, right? You can also check with the other metrics as well, right? So let's see. We see that we have 99.9%, right? And 99.9 just like 100%. All right, now let's actually see let's actually use the confusion metrics. We've used the accuracy, right? So let's check the performance metrics again and then see. So I'm going to use the confusion metrics over here and then see how it is doing. So I use that one on the Y test and then the Y predict, just like we did earlier on. Okay, then let's see the output. Now in this case, you can see that there's an improvement in this, right? Although we have 99.9% again, but in this case you can see that we having an improvement. Unlike if you go up here and we see the confusion metric that we have it, right? We see that we're making mistakes here, right? We're making 19 mistakes here when in regards to the zeros, right? 19 of the zeros we predicted them as 1, right? And then 7 of the ones we predicted it as 0. Okay, and the correct predictions are this, right? And then this one too. But if you see the random forest over here, if you see the random forest that we built, we can see that now we can see that we are not making any mistake when it comes to the zeros, right? And you can see that even the mistakes that we're making for the ones which was 7, now it has reduced to 5. Okay, it has reduced to 5. So what we are trying to do is to reduce the errors that we are making, right? We want to reduce these errors that we are making, and you can see that when we change the algorithm, we can see that we have been able to reduce the errors that we are making. Okay, so changing the algorithm also works. It's also one of the ways that you can actually use to deal with this data imbalance. Okay, so don't stick to one algorithm if it's not working for you. All right, now let's actually also see the F1 score, right? The F1 score and the recall for this for the for the random forest, right? So if we check that, so the code is just the same thing like we did earlier on. Okay, so now you can see that we are now getting closer to 1, right? We have a huge improvement in there, right? We have a huge improvement in, now we have 87 or 8, which is closer to 1, or 100% over here. So now this one is actually reflecting what we have, or the accuracy that we have is actually matching with that. It's better than what we were having where earlier on, where you see that this one was bad, right? This one was bad. Now you can see there's an improvement when we change the performance. When we change the algorithm, right? So this is one of the techniques that you can also use, changing the algorithm. All right, now the next one we're going to talk about is the resampling techniques, right? That we can also use to deal with when you have data imbalance. Okay, so let's see how this resampling techniques works, and the various resampling techniques that we have.